Preparing for a solutions architect at Elastic interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does a solutions architect do at Elastic? A solutions architect connects customer goals with a practical technical design. At Elastic, I would discover the business problem, map it to search, observability, or security use cases, and demonstrate how Elasticsearch and related capabilities address it. I would also discuss architecture, deployment, integrations, performance, security, and adoption. My responsibility continues beyond a demo. I help establish success criteria, manage technical risk, and create a path from proof of concept to production value. While answering, focus on translating business requirements into technical architectures, demonstrating Elastic capabilities, influencing stakeholders, validating feasibility, and balancing customer outcomes, scalability, security, cost, and implementation complexity. Question 2. How would you discover a customer's requirements before proposing an Elastic solution? I begin with the business outcome rather than the product. I ask who uses the system, what decisions it supports, where current workflows fail, and how success will be measured. Then I quantify data volumes, query patterns, latency, retention, availability, security, integrations, and operational constraints. I validate assumptions with multiple stakeholders and summarize them in writing. Only after that do I recommend an Elastic architecture, because accurate discovery prevents an impressive but irrelevant demonstration. Make sure to cover business objectives, users, data sources, current pain points, scale, service level expectations, compliance, budget, decision criteria, existing architecture, and questions that distinguish symptoms from root causes. Question 3. When would you recommend Elasticsearch instead of a traditional relational database? I recommend Elasticsearch when the core requirement is fast, flexible retrieval across large or evolving datasets, especially full-text search, relevance ranking, filtering, aggregations, or near real-time analytics. A relational database remains preferable for complex transactions, strict relational integrity, and authoritative records. In many designs, the systems work together. The database is the source of truth, while Elasticsearch provides an optimized search and analytics experience. I would choose based on workload characteristics, not technology preference. In your answer, talk about search relevance, flexible schemas, distributed scale, analytical queries, full-text capabilities, low-latency retrieval, transactional requirements, consistency expectations, and situations where Elasticsearch should complement rather than replace a database. Question 4. How would you design an Elasticsearch cluster for a high-volume production workload? I would start by measuring indexing throughput, query concurrency, document size, retention, latency targets, and recovery objectives. I would distribute nodes across failure zones, separate workloads when necessary, select appropriate storage, and size shards to avoid both oversized recovery units and excessive overhead. Replicas support availability and search capacity, but I would validate their cost. Finally, I would load test realistic traffic, monitor JVM pressure, disk, rejections, and latency, then document scaling triggers. Be sure to mention workload characterization, node roles, shard sizing, replicas, availability zones, storage, memory, ingestion rate, query concurrency, retention, monitoring, failure domains, and testing with representative production data. Question 5. Explain Elasticsearch indexing and search at a high level. Elasticsearch stores JSON documents in indices, with mappings describing field behavior. During indexing, text is analyzed and organized into structures such as inverted indices, allowing efficient term-based retrieval. An index is divided into primary shards, with replicas providing resilience and additional search capacity. Writes are coordinated across the cluster, while refresh operations make recent changes searchable. Queries are distributed to relevant shards, and results are merged according to matching and relevance rules. Focus on documents, indices, mappings, inverted indices, shards, replicas, refresh behavior, distributed coordination, relevance scoring, and the distinction between indexing availability and immediate search visibility. Question 6. How would you troubleshoot slow Elasticsearch searches? I first determine whether the delay is in the client, network, coordination, or shard execution. I inspect slow logs, query profiles, cluster health, CPU, memory, disk latency, thread pools, and rejected requests. Then I review mappings and query structure, looking for expensive scripts, broad wildcards, deep pagination, high cardinality aggregations, or too many shards. I test a representative query with realistic data and improve one variable at a time, confirming gains through measured latency and throughput. Discuss reproducing the issue, identifying query patterns, examining profiles and slow logs, checking shard count, mappings, caches, resource saturation, aggregations, data volume, pagination, and separating client latency from cluster latency. Question 7. What is your approach to designing relevance for an enterprise search application? I begin by collecting representative user queries and defining what a successful result means for each intent. I design fields and analyzers deliberately, then combine full text matching with filters, boosts, phrase logic, synonyms, and business rules. I avoid relying only on intuition. I create a relevance test set, compare results, and review failures with domain experts. If behavioral data exists, it can inform ranking, but I preserve explainability and monitor for unintended bias. In your answer, cover user intent, analyzers, fields, boosts, synonyms, filters, business rules, behavioral signals, relevance evaluation, explainability, multilingual content, and iterative testing with representative queries. Question 8. How would you use Elastic Observability to investigate a production incident? I would establish the incident window, affected services, and user impact, then correlate metrics, logs, and distributed traces through shared identifiers. Metrics can reveal when and where saturation began. Traces expose slow dependencies. Logs provide detailed event context. I would use dashboards, alerts, and service maps to narrow the fault domain, validate hypotheses against deployment or infrastructure changes, and communicate clearly. After recovery, I would improve instrumentation, alerts, runbooks, and capacity planning. Make sure to cover unified logs, metrics, traces, infrastructure context, time correlation, service dependencies, alerting, anomaly detection, root cause isolation, collaboration, and converting findings into preventive actions. Question 9. How would you position Elastic Security to a customer evaluating SIEM platforms? I would position Elastic Security around the customer's detection and investigation outcomes, not a generic feature checklist. I would explore data sources, detection coverage, analyst workflow, response processes, retention, cloud strategy, and existing investments. Then I would demonstrate how centralized telemetry, rules, machine learning, entity context, timelines, and integrations reduce investigation time. I would quantify success through coverage, alert quality, mean time to detect, and mean time to respond, while acknowledging migration and operational requirements. Discuss security analytics, data ingestion, detection engineering, investigation workflows, endpoint and cloud context, automation, deployment flexibility, total cost, existing tools, measurable outcomes, and avoiding unsupported product claims. Question 10. How do you explain the difference between Elastic Cloud and self-managed Elastic deployments? Elastic Cloud reduces operational burden by providing managed provisioning, upgrades, scaling options, monitoring, and support for the Elastic Stack. Self-managed deployment offers greater control over infrastructure, networking, customization, and sometimes residency requirements, but the customer owns patching, capacity, reliability, and upgrades. I would compare both options against regulatory needs, skills, cloud strategy, integration constraints, availability objectives, and total cost. The right recommendation depends on ownership preferences and business requirements, not simply deployment fashion. Be sure to mention operational ownership, deployment flexibility, upgrades, scaling, networking, data residency, security controls, customization, staffing, cost models, and selecting the option according to customer constraints. Question 11. How would you migrate a customer from another search or logging platform to Elastic? I would inventory data sources, queries, dashboards, alerts, retention policies, integrations, and operational dependencies. Next, I would prioritize critical use cases, map schemas and timestamps, design ingestion pipelines, and translate queries or detection logic. I prefer a phased migration with parallel validation, comparing completeness, latency, results, and alert behavior before cutover. I would maintain rollback options, train users, and define adoption metrics. Migration succeeds when workflows improve, not merely when data reaches the new platform. Cover discovery, inventory, use case prioritization, data mapping, ingestion design, query and dashboard conversion, parallel operation, validation, cutover, rollback, training, and adoption measurement. Question 12. What is your process for running a successful technical proof of concept? I define the customer's decision and measurable success criteria before building anything. For example, the proof of concept might target sub-second search, improved detection coverage, or reduced investigation time using representative data. I agree scope, owners, timeline, architecture assumptions, and evaluation methods with stakeholders. During execution, I document limitations and validate integration, security, scale, and usability. I finish with results, lessons, production requirements, and a clear recommendation rather than treating a demo as proof. In your answer, mention explicit hypotheses, success metrics, representative data, agreed scope, stakeholder alignment, timeline, technical validation, business value, risks, and a production transition plan. Question 13. How do you handle a customer requirement that Elastic cannot fully satisfy out of the box? I first clarify the business outcome and test whether the stated requirement is truly mandatory. Then I examine native capabilities, configuration, integrations, APIs, and feasible workarounds, while considering supportability and long-term maintenance. If a gap remains, I explain it directly, quantify the impact, and offer alternatives with trade-offs. I would not promise an unsupported capability to win a deal. Trust improves when customers understand constraints and still receive a practical path forward. Focus on clarifying the underlying outcome, distinguishing must-haves from preferences, evaluating configuration and integration options, stating limitations honestly, proposing alternatives, assessing risk, and documenting trade-offs. Question 14. How would you secure an Elastic deployment? I design security in layers. Identity should integrate with the customer's provider, using least privilege roles and clear separation between administrators, applications, analysts, and data owners. I would encrypt traffic and storage, isolate networks, protect credentials through approved secret management, enable audit visibility, and restrict sensitive fields where appropriate. I would also address tenant separation, backups, patching, vulnerability management, and compliance evidence. Finally, I validate access paths through testing rather than assuming configuration is secure. Discuss identity and access management, least privilege, encryption in transit and at rest, network isolation, secrets, audit logging, tenant separation, compliance, patching, backup protection, and continuous review. Question 15. How do you balance performance, reliability, and cost in an Elastic architecture? I make the trade-offs explicit by ranking workloads and defining service levels. Hot, latency-sensitive data may require faster storage and more replicas, while older data can move to less expensive tiers with different retrieval expectations. I would optimize mappings and queries before simply adding infrastructure, then model ingestion, storage, replica, and operational costs. Reliability still requires appropriate redundancy and recovery testing. My recommendation would show at least 2 viable designs, their assumptions, and the business impact of each. Be sure to mention workload priorities, service levels, data tiers, retention, replicas, resource sizing, autoscaling, query optimization, failure tolerance, observability, and presenting transparent cost-performance trade-offs. Question 16. Tell me about a time you influenced stakeholders who disagreed with your technical recommendation. In one project, engineering favored a highly customized design while operations wanted a simpler managed approach. I first documented their concerns, then compared both options against availability, security, delivery time, skills, and 5-year cost. A small benchmark exposed where customization added value and where it introduced unnecessary risk. I presented the findings in business language, proposed a phased compromise, and gained agreement. The project launched on schedule, and we reserved customization for a later, evidence-based decision. In your answer, use a structured example showing conflicting priorities, listening, evidence, alternatives, communication to different audiences, decision criteria, compromise, and the measurable outcome. Question 17. How would you explain a complex Elastic architecture to a non-technical executive? I would start with the executive's priority, such as reducing outages, improving customer search, or lowering investigation time. I might describe the platform as a fast, centralized layer that organizes operational data and makes important signals easier to find. Then I would show a simple architecture, expected outcomes, timeline, cost drivers, risks, and success measures. I avoid unnecessary terminology, but I remain precise about assumptions. Technical depth can follow when the audience needs it. Focus on business outcomes, simple analogies, decision-relevant metrics, risk reduction, cost, timeline, assumptions, visual storytelling, and adapting detail to the executive's priorities rather than presenting every technical component. Question 18. How do you keep your Elastic knowledge current? I combine structured learning with hands-on validation. I follow Elastic documentation, release notes, technical blogs, and community discussions, then test relevant capabilities in a small lab using realistic data. I also learn from customer projects, peer reviews, enablement sessions, and post-implementation lessons. When discussing a new feature, I distinguish what I have personally tested from what I understand conceptually. That discipline helps me give accurate guidance and identify when specialist input is appropriate. Mention product documentation, release notes, hands-on labs, certifications, community resources, customer implementations, internal collaboration, architecture experiments, and distinguishing tested knowledge from assumptions. Question 19. What would you do if a proof of concept works technically but the customer still does not want to proceed? A technical success does not guarantee a business decision, so I would ask what remains unresolved. The objection could involve budget, ownership, migration effort, security approval, competing priorities, or insufficient executive value. I would revisit the original success criteria, quantify benefits, and involve the right stakeholders. If necessary, I would propose a narrower first phase or different deployment model. I would document lessons and maintain trust, even if the customer chooses not to proceed immediately. Discuss uncovering the real objection, revisiting success criteria, stakeholder alignment, commercial and operational barriers, adoption readiness, quantified value, alternative scope, and preserving the relationship without applying pressure. Question 20. Why do you want to be a solutions architect at Elastic? I am drawn to Elastic because its platform addresses problems I enjoy solving, finding information quickly, understanding system behavior, and turning security or operational data into action. The solutions architect role combines architecture, communication, discovery, and measurable customer impact, which matches my strengths. I also value the need to learn continuously as use cases and technologies evolve. I would bring technical credibility, commercial awareness, and a consultative approach that helps customers move confidently from evaluation to adoption. Be sure to connect Elasticsearch, observability, and security platform to your experience, customer-facing motivation, technical curiosity, communication strengths, learning mindset, and evidence that you understand the role's responsibilities. If you are still with us, congratulations, You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.